Today we are going to do the type of reactions lab. In this lab there's 9 little mini procedures, so we're going to see 9 different types of reactions. So let's see the first one. The first reaction deals with a piece of magnesium ribbon. So let me zoom in for you. So notice the shiny and lustrous nature of that magnesium ribbon. We are going to burn the magnesium ribbon in the presence of oxygen gas. And let's see what our products are. Now this reaction produces a really bright white light, so you'll want to definitely not look directly at this, but our camera is probably going to take care of that for you. This is our magnesium metal now after we've burned it. It's not shiny anymore, it's kind of a white powder, whitish gray. So go to your data table, write down all of your observations for that first procedure, and write a balanced chemical reaction for the reaction between magnesium and oxygen gas. So for procedure 2, we have a sample of calcium oxide, which is just like a white powder. And we want to take litmus paper and test this dry white powder to start off the procedure. We want to make sure it's not an acid or a base to start. So here's my red litmus paper. And there was no color change. If red litmus paper turns blue, that means that you have a base. So there's my blue litmus paper that I just tested, and there was no color change for the solid as well. So if blue litmus paper turns red, that means we have an acid. But since neither litmus paper changed, we have neither an acid or a base to start. So here's our calcium oxide sample again, but I added water. So I wanted to test the water solution for the calcium oxide and see if in fact we have an acid or a base now. So here's my red litmus paper. Oh, and that turned blue. So that means that this was a positive test for a base. So let's try the red, or the blue litmus paper to see if it turns red. Nope, it's still blue. So our red litmus paper indicates that we have a base. So this indicates that we have a hydroxide ion present. So the reactants were magnesium or calcium oxide and water, and it produced a hydroxide. So go into your data table, record your observations, and write a balanced chemical reaction. Okay, for procedure number 3, we have copper 2 sulfate pentahydrate in a test tube. So it's that nice bright blue color because of copper being present and the fact that it is hydrated, so it's got water in it. So we're going to heat that copper 2 sulfate pentahydrate for about 3 minutes. Notice, even since we just started heating, that there's some water vapor being given off. The 3-minute heating has just completed, and notice I still have a little bit of blue, so we didn't get rid of all the water, but notice that most of it is like a white color now. That's because the copper 2 hydrate has been dried out, and so now we have an anhydrous copper 2 sulfate. So go ahead and look at your data table, write down all of your observations, and write a balanced chemical reaction for what you just saw. For the 4th procedure, I've added 5 milliliters of hydrochloric acid solution to a test tube, and I'm just putting it in an Erlenmeyer flask just to hold it in place. And we're going to add zinc metal. So it's starting off as that like grayish white color. It should be a little more gray. The zinc's oxidized a little bit over time, but it's still good for today's lab. So I'm going to add our zinc to the hydrochloric acid. And you guys notice that it's starting to bubble. So we see bubbles forming. So we are releasing a gas as this reaction proceeds. Since this was reacted for a little while, we want to bring a flaming splint to the top of the test tube. This is a test for a flammable gas. So if we're producing a flammable gas, we should see some ignition here. Maybe even a loud noise. So you saw the flame kind of jumped into the test tube and back out. So the gas inside that test tube that we're producing ignited. So whatever this gas is must be flammable. So look at those reactants. and try to figure out what kind of gas is being produced. So go to your data table for procedure 4, write out a balanced chemical equation for what you see, and make sure to write down all your observations for everything you just saw. For procedure 5, we're going to use this piece of zinc, and we're going to use that copper 2 sulfate solution. So this one takes a little while, so I'm going to add my piece of zinc to copper 2 sulfate and the solution of copper 2 sulfate, and let's see what happens. All right, so I just removed our piece of zinc from the test tube, and notice that a reddish brown substance is starting to form on the outside of the zinc. So this is indicating that there's some kind of replacement reaction going on, since the copper is leaving the solution and entering onto the piece of zinc. So write down all of your observations in the data table and make sure to write a balanced chemical reaction for what you just saw. So for procedure number 6, we're going to use this piece of copper wire. So it's got a nice copper color to it, it's shiny. And we're going to use a silver nitrate solution, which is just a clear liquid. So I'm going to add our piece of copper wire to that silver nitrate solution, and we're going to come back in about 10 minutes and see what happened. Right, so now that 10 minutes is gone, we can notice that the copper wire is still there. Kind of hard to see for you guys. But I have like a gray substance that formed. You can kind of see it swirling around. The copper wire is still in the bottom, but I have this shiny gray thing that's just formed on the surface of the copper wire. So it looks like we have another type of replacement reaction going on here. So write out all of your observations in the data table for procedure number 6, and write out a balanced chemical reaction for copper and silver nitrate. For procedure 7, we're going to use calcium metal. So it's got this like gray color to it, and I'm going to add it to water. Now I've actually already started this reaction for you guys so that you can see what's going on. But we have some bubbling. So the calcium metal is reacting with the water, and we've got a nice bubbling going on here. I want to test that solution with litmus paper to see if I have an acid or a base. Water is already neutral to start, but now that I've added that calcium metal, we've slightly changed the acidity, so we have an acid or a base. All right, so here's my blue litmus paper. And let's extract that. So my blue litmus paper is still the same color. It's still blue. So I still have the same color from my litmus paper, so this does not indicate an acid. So let's try the red litmus paper. So the red litmus paper has turned blue. So this indicates that we have a base present. So make sure you write down all of your observations in the data table and write out a balanced chemical reaction for everything you just saw. And this base indicates, just like the last reaction, that there's a hydroxide present as one of your products. So right here, for procedure number 8, so I have a solution of sodium chloride right here, and we're going to mix it with silver nitrate. So this happens really quickly, so make sure you're paying attention. So you see that a white solid was produced. So we have a white precipitate from that reaction. So write down all of your observations for this step and write a balanced chemical reaction for sodium chloride and silver nitrate. Procedure 9, we are going to mix together 5 milliliters of 0.1 molar NaOH with 5 milliliters of 0.1 molar HCl. I already have them pre-measured out, so we're going to do the reaction right in that evaporating dish. And they both started out as like clear liquids, as you can see. Now the resulting solution is still a clear liquid. So we're going to take this over to the burner, and we want to heat this until all of that excess water from the solution is driven off. So we'll put this over our burner. And we want to boil off all that water and see what happens. All right, so we boiled off all the water and we have this white residue left behind. So write all of your observations in your data table and write out a balanced chemical reaction for this reaction. Remember, HCl reacted with NaOH, so try to figure out what this white compound is. So now that the entire lab has been completed, make sure that your entire data table is full, you have all of your observations written down, and you have a balanced chemical reaction written for every single part of the procedure.